So we begin. Chapter 3. We're going to describe relationships. So we really want to talk about how do we know if he really likes me? How do I know if she really... No, I'm just kidding. We are talking about how two variables relate, though, and that is relationships. How two things relate. So this is stuff you've probably at least heard of before, maybe even done with me some in pre-cal before. But this is scatterplots and correlation for this section. So just truthfully, this is one of the easier chapters, and we save it for this long because we'll be doing more with scatterplots, correlations, and regression later in the year. So I try to keep it closer to that chapter so it isn't so far away in our brains how to work that once we add in some good confidence interval and significance test type stuff with it. I know, stuff to look forward to. But right now, it's just the basic describing relationships. You don't have to worry about the more complicated scatterplots and significance tests for this chapter. Enjoy. So here's our goal in this section. Identify explanatory and response variables, construct scatterplots, display and will describe the relationships, then I guess this is what they mean, interpret the scatterplots, measure linear association using something called correlation, and then interpret that correlation. So let us begin. We'll talk about explanatory and response variables first. So most studies in statistics examine data on more than one variable. In many of these settings, the two variables play different roles in how they affect each other. So a response variable measures an outcome of a study. An explanatory variable may help explain or influence changes in a response variable. So a response variable tends to be our y values in what we're going to be using. Our explanatory variable tends to be our x values. The explanatory tends to be, well, I'm getting ahead of myself, so let me pause right there. Alright, and there it is. In many studies, the goal is to show that changes in one or more explanatory variables actually cause changes in a response variable. However, other explanatory response relationships don't involve direct causation. We'll talk more about cause and effect throughout this chapter because that's something that sometimes when we see statistics and studies posted in the media, either the people reporting on it or even the people who made it weren't very careful, because we have to be careful when we talk about cause and effect with statistical studies. But just a quick example, when we're talking about global warming, the argument is that they have seen that an increase in carbon dioxide and other similar gases in our atmosphere has caused an increase in temperature. So in that, the response variable would be the temperature. The explanatory variable would be the amount of carbon dioxide or methane or other similar greenhouse gases. So right now I want you to turn to page 144 and complete the Check Your Understanding questions. So please pause this video right here and take some time to finish that, and then just hit play when you're done. Alright, so you should be done now. Here you go. You can see what the explanatory and response variable were for each of these. Notice in number 2 we had two explanatory variables. Okay, one way we can display the relationships is with the scatter plot. That's the way we can show the relationship between two quantitative variables. So here's the official definition. A scatter plot shows the relationship between two quantitative variables measured on the same individuals. The value of one variable appears on the horizontal axis, and the values of the other variable appear on the vertical axis. And each individual in the data appears as a point on the graph. So how to make a scatter plot? Because you need to know how to graph, right? You decide which variables should go on each axis. In general, the explanatory variables go on the x-axis, response variables on the y. And there it is right there. So remember, explanatory variables go on the x-axis. This is an important thing to remember. You've got to label and scale your axis. So scale, we're talking about marking like 1, 2, 3, 4 on the dashes. And you can go by other numbers. You can go up by 2s or by 5s or by 10s or by 20s or by 100s as long as you're consistent. So you need to all the way across go with the same increments. You should also label the axes to show what they're representing, show which variable is with which axis. And then you plot the actual points, the data values. So here's an example. This is a scatter plot we're going to make of the relationship between body weight and pack weight. Now we would assume the body weight is our explanatory variable, and just to explain a little bit about why, we figure it makes sense how big someone is does have an effect on how big of a backpack is comfortable for them to carry, whereas the size of the backpack doesn't really change or affect how large someone is. Someone who's very small doesn't suddenly just grow huge if they try to carry a big backpack, or someone who's very big doesn't suddenly grow small just because they carry a very light backpack. So it makes more sense that the body weight explains the backpack weight, so that's why the body weight will be the explanatory variable. So we mark it. Notice they went from 0, and then given where the numbers were, they just went from basically 100 to 190 is what they're trying to show. And they label and scale the axis. They label it body weight, and they note the unit, pounds, and they also scale it, the 0, 110, 120, 130, and so on. We'll do the same thing with the backpack weight. We label it pack weight in pounds, and we scale it. And you can see now it was 100 there at the base. It was just blocking the 10 of the 100. So the x-axis is scaled from 100 to 190. The y-axis is from 20 to 36. And they're choosing these scalings based on what data we have, what makes the most sense based on that. So now that we have we've chosen which one goes where on which axis, and we have labeled and scaled our axis. So now it's time to plot our points. So you can see they're marking an example for the very first one where the person who weighs 120 pounds is carrying a backpack that is 26 pounds. As far as interpreting, this is important. We're going to follow the basic strategy of data analysis back from chapters 1 and 2, which I know you remember all that stuff we did back in chapters 1 and 2, but we're going to look for patterns and look for important departures from those patterns. So here's how to examine a scatter plot. As in any graph of data, look for the overall pattern and for striking departures from that pattern. And these are the three things we want to focus on describing: the direction, the form, and the strength. And we'll talk about what those mean and what words we'll use as we do some examples. But you need to remember, when you're asked to examine or describe a scatter plot or interpret a scatter plot, those are the three things you should focus on: the direction, the form, and the strength of the relationship. And any important kind of departure is an outlier, and usually we'll just be looking for one that visually strikes us as an outlier. We're not going to be computing it most of the time with IQR or anything like that, just looking for something that appears to be an outlier. So let's interpret this scatter plot based on the body weight and the backpack weight. So there is a moderately strong, positive, linear relationship between body weight and pack weight. It appears that lighter students are carrying lighter backpacks. So let's talk about how this statement does those three things. So it talks about the strength. It's moderately strong. That means it does look pretty close to a line. It does also have a pretty clear direction as far as we move right on the graph. It does tend to move in the same direction of moving up. And then the direction is positive for the same reason I was talking about. It's got a positive slope. That's really the simplest way to think about it. Is if, as you move from left to right, you're going uphill, that's a positive slope. It's also a positive relationship. In other words, they tend to go the same direction. As one goes up, the other goes up. As one goes down, the other also goes down. And the form you can think of as the shape. This is fairly linear. It overall looks like it's a straight line, or is very similar to a straight line. And we'll mostly be looking at linear things. But if it's not linear, curved is one thing you can describe it as. So you see, we talk about the strength, the direction, and the form in this description. And there's one possible outlier: the hiker with a body weight of 187 pounds. They seem to be carrying a relatively less amount of weight in their pack than are the other group members. That's the one that is farthest away from the line we've drawn. So that looks like a possible outlier. All right, so definitions for the direction with positive and negative. Two variables have a positive association when above average values of one tend to accompany above average values of the other, and when below average values also tend to occur together. So as I said in the previous slide, they both tend to move the same direction. Either when one goes up, the other is too, or when one goes down, the other is as well. Now, two variables, sorry about that, two variables have a negative association when above average values of one tend to accompany below average values of the other. So in this case, they move the opposite direction. As one goes up, the other tends to go down. Or as the first goes down, the other tends to go up. So they have a negative association when they move in opposite directions. This is going to look like a negative slope on our graph. As we move from left to right, the data points will move down. So here's an example you can see on page 144. It's showing the percent of people taking an SAT and the mean math score for some schools. So this is an example of a negative association. You can see the smaller the percent taking the SAT, the greater their mean math score. The greater the percent taking the SAT, the lower their mean math score. So these two variables move in opposite directions. That's what gives them a negative direction or a negative association. We can also note that it is curved as far as its form, and as far as its strength, we can say it's moderately strong. Now it's okay, it's not a straight line, but the points generally stay close together in the direction they are going, so that's why we say it's moderately strong. So it's moderately strong, that's its strength. It's negative, that's its direction, and curved is its form, between the percent of students in a state who take the SAT and the mean SAT math score. Further, there are two distinct clusters of states and two possible outliers that fall outside the overall pattern. That would be the two you see that are a good bit below, the one that looks maybe around 20% and 500, kind of on the left side, and then the one way out to the right. Those look like they could be possible outliers. I'm going to back up just so you can see the two realms. If you look at the 30% mark for the SAT, it almost seems like we have one group off to the left and then another group off to the right. There seems to be kind of two separate groups here. All right, it's moving forward. Give it just a moment. We'll move on. So that is the two distinct clusters it's talking about. Okay, so they're showing you the strength, the direction, and the form. So make sure you get it in your head that those three things are important when we are interpreting a scatter plot. So now I want you to turn to the check your understanding questions on page 149. So please, someone pause this video until you guys are done, then hit play again when you're ready to see the answers. Cool, let's check it out. So here's the answers for 1 and 2. The relationship is positive. The longer the duration of the eruption, the longer the wait between eruptions. One reason for this might be that if the geyser erupted for longer, it expended more energy, and it will take longer to build up the energy needed to erupt again. Number 2, the form is roughly linear with two clusters. The clusters indicate that in general, there are two types of eruptions, one shorter, the other somewhat longer. And feel free to pause if I'm going through this too quick. The relationship is also fairly strong, 2 points define a line, and in this case we could think of each cluster as a point, so the two clusters seem to define a line. There are a few outliers around the clusters, but not many, and they're not very distant from the main grouping. The Starnes family needs to know how long the last eruption lasted in order to predict how long until the next one. So in this case, it would seem that the length of the eruption is the explanatory variable that affects the response variable, which is how long it is till the next one, or how long it is between two eruptions. Alright, I know, 4-step process, but this is mostly just to keep us in the rhythm. I assure you, with this, it is much shorter than the ones we've been doing with confidence intervals and significance tests. I just want to keep us in this pattern. So here's what we do for the state. What is the relationship between, and then talk in context about the explanatory variable and the response variable. Plan. well, they have things they want you to do in the book. I say no. So this is just Mr. Lin saying, don't worry in this chapter about the plan section. And on the AP test, you don't have to really do the 4 steps of these either. This textbook's just trying to get you in the rhythm ahead of time. But I'm saying don't worry about the plan section. For the do, you need to show the scatter plot, describe the overall pattern, showing the 3 things, direction, form, and strength, and talk about any outliers. So you're really showing the scatter plot, describing its pattern, and any departures from that pattern. And then conclude. In context, say something like, as the explanatory variable increases or decreases, the response variable increases or decreases. You can say it does this linearly or in a curved section, moderately strongly, things like that. So page 148 gives you a good example if you want to see it. But just make sure you do it in context. So don't say, as the explanatory variable, say something like, as the length of the eruptions increases. Okay, that completes the first part of this section. There's your homework. Good luck.